Number 16 refers to a sum or difference of cubes. So each one of these has like x cubed minus 1 cubed. Here this would be x cubed minus 3 cubed, x cubed plus 1 cubed, and x cubed plus 4 cubed. Now we could break this down using factor properties and synthetic division. However, and that's perfectly fine if we do that, and that's what they kind of expect you to do. However, there are formulas for difference of cubes and sum of cubes, and the formulas look like this. So when I factor x cubed minus y cubed, it factors into x minus y. So for this one, it would look like this: x minus 1, x squared plus xy plus y squared. So it becomes x squared plus xy. Oops, sorry, that's gonna, plus xy, so it's going to be plus 1y plus 1 squared. So it's going to look like that. X squared plus, my mistake here, it's going to be x squared plus x plus 1. And if you expand that out, you'll be able to get back to the x cubed minus 1. And this quadratic here is not factorable. Okay, so that's as far as we can go. And so we can actually just use this formula. Now this is a very useful formula to know, and both of these are useful formulas to know. But if you forget them, you can always break this down using factor properties and synthetic or long division. So in this case here, one of my factors is going to be the cube root of 27, which is 3. And if it's minus here, it'll be minus here, and we end up with x squared plus 3x plus 3. Okay, and so plus 3 squared, which is 9. Okay, so that's as long as we follow that formula, we'll get it. And same with the plus part. Now the plus is easy because it's the same as a minus, except if it's plus here, we get plus here, and then it switches sign over here. So this is minus here, and it switches signs over there. So this becomes x plus 1, x squared minus x plus 1. And this one becomes x plus 4, x squared minus 4x plus 16. Okay, so there's our factored forms. Now it says use the results from part A to decide whether x plus y or x minus y is a factor of x squared plus y, x cubed plus y cubed. If it's plus, we use plus, and if it's minus, we can use minus as a possible factor. So the other factors then end up being these ones here. So for x cubed minus y cubed, the other factor would be the quadratic left over here, and for the plus, it's the quadratic left over here, and these are not factorable. Okay, those are non-factorable quadratics. So the part C says use the result from part A to decide whether x plus y or x minus y is a factor of x cubed minus y cubed. Well, we know that, we can see from the patterning that if it's minus, we have minus. If it's plus, we have plus. So here we can decide that x minus y will be a factor of the x cubed minus y cubed. So it's good. We can break this down and come up with these answers to these questions, but really I think it's very useful to know how to factor a sum and difference of cubes, because there are formulas for that. Lastly here, we can use this, and we're going to use a formula to factor x6 plus y6. So we're going to factor this into the cube root of x squared. X6 is x squared, and since it's plus, we're going to use a plus, so we're going to get x squared plus y squared. And then since that's a sum of squares, we cannot factor that, and we're going to then end up with x squared squared, and if it's plus, we're going to use the minus form. It's going to be x times y, so it's going to be x squared y squared, and then plus y squared, so y squared squared is y to the power 4, and we can always check this by expanding this out, and this is our fully factored form because we have a sum of squares, which is non-factorable, and we have this fourth degree polynomial which is non-factorable as well.